Right, we're starting on page 228. It's the first question on the rotations chapter. The full example is done out for you, so it'll be a little bit of a help when you're getting the question done. First thing is setting it up. You've got a pile of measurements here, 15, 70, 40, 15, and then you have a load of measurements down the side. Basically what it means, we draw our XY line. It's 100 millimeters high, 140 millimeters wide, and then we can set in the grid. So when I come to the sheet there, keep close to the top of the page. When you're doing the question, step down maybe 120 mil from the top. So we want it up close to the top and in the right hand corner. The measurement, 100 high, 140 wide. We draw the box. Our grid, step over 15, 70, 40, and that leaves 15 on the end. And then when we're working up the way, it's just 20, 15, 15, 15, 15, and 20 left on the top. And then you can set out a grid, and that let us put in the shape of the arrow. I have the arrow put in. Now we need to draw the plan view of the sign. To draw the plan view, step down 20 mil, and we just draw a line across. So it's a flat vertical surface, that's why it looks like a line in plan. So our elevation is here, and then the plan looks like a line. Now back to the question. The figure shows the elevation and plan of a direction sign. The sign is pointing in an easterly direction. On the same elevation, draw the given elevation. On the same XY line, draw the elevation when the flag is pointing in a southwesterly direction, as indicated by the dotted line. So the flag, and if you think of a compass, here's the compass view in plan, it's pointing easterly. They want it to change to a southwesterly direction, which is just a 45-degree angle down in that direction. So when I come to do that, the sign is originally here, we need to change it to a 45-degree direction down there. So we've got our starting position, and we're going to end up with a new position. Now, as always, we're going to label the drawing. So we'll call the corners 1, 2, 3, and 4. That's our elevation view. When we come down to the plan, the points are directly below. So 1 is here, 2 is in the same position because 1 is directly over 2. 3 and 4 are in the same position because 3 is directly above 4. Now we have to rotate this sign into a new position. So when it moves in plan, it's also going to move the elevation. So we're going to end up with a brand new sign that's going to basically flip over. So if we took, for example, with the phone, what's going to happen is the phone is going to flip right over and into a new position here. And we're going to draw the elevation and plan of that. In the plan view, it's as if that phone is going to be hinged here, nailed here, and I'm going to swing the phone around into the new position. So it rotates around. So that's where the new phone is going to be in plan. So that's the movement we're going to make with it. To do that, we use the compass. Our hinge point is here, because the joint between the two lines, and we move points 3 and 4 around. So we swing points 3 and 4 around about. Right around until it hits our line. So point 3 and 4 both come around and they hit at the new point here. So what we've done is we've got the sign and we've moved it from this position to this position. We've got our plan. We need to draw an elevation. So we're just going to project an elevation up from the plan like we always would. So if I want to draw an elevation, I project my lines straight up. 1 and 2 are staying in the same position, so I don't need to worry about those. 3 and 4 are just going straight up. The height of them won't change. So point 3 and 4 have been projected straight up. The height of point 3 is over here. It's not going to change, so I just project straight across. So I take 3 straight across to form my new point 3. Here's point 3. So 3 was brought straight across. Point 4 is the exact same thing. Here's point 4. And again, its height doesn't change, so it's already done for me. It comes straight across. And there's point 4. And that gives me the new position of the sine. So here is my new sine. And it looks kind of squashed, exactly like the phone does. When I get the phone left down flat, it looks really wide. When I take the phone and flip it up over, it looks much narrower. So now it's a lot narrower than it was. That's the exact same principle. Right, we're moving on to the arrow. The arrow is written on the sign or drawn on the sign. I've labelled it up. It's the exact same principle. If I look at my phone again, the Samsung is written on the phone. It's flat on the phone. When I look down and plan at that, I can't see it, but I know it's here. That's where the Samsung sign is. So when I move it from there, that's the elevation, to the plan, which is here, the writing is here. It's the same thing. Even though the sign is flat, I know that this arrow is down here. And again, to find the points where it is, I can't see it, but I bring the point straight down. So point A, straight down. B, C, F and G are all directly above each other, so they're all going to form the same line. So when I take those down, that one point represents the position of B, C, F and G. And likewise here, when I come back, these 2 points are lining up, so when I bring the 2 of those straight down, those are going to end up being down here. So that gives me the points for all of those. That's D and E. I've got my points labelled in elevation. I've got my points labelled in plan. I need to bring those points to the new elevation and plan. And we'll start with that. Again, the same thing. If the sign moves, that arrow has to move with it. Compass point goes on the hinge, which is 1, 2. And I swing around point A. So I stretch out to point A and swing around. And that gives me the new position for point A. This is a pretty quick question because B, C, F and G are all come together. So all of those points move around together. And D and E the same. Compass point stays on the hinge point all the time. I've got my points in plan. I need to find those points in the elevation. And again, point A. And point A is going to be exactly the same as every other point. Point A comes straight up into elevation. The height of it doesn't change, so A comes across. B, exactly the same. B comes up, B comes across from elevation. C comes up, C comes across. D comes up and D comes across. Same with E. E comes up. So point E comes up. Point E comes across the T-square. F is here. So F is brought straight up and F comes straight across. Likewise for G. G from plan brought straight up, and G, which is here, straight across. And it's just like join the dots. A, B, C, D, E, F, G, back to A. Again, all I got to do here is join the dots. I don't need to think about what it's going to look like. A to B, to C, to D, E, F, G, and back to A. And that is our rotation complete. Here is the sign, and you'll see it's back to front. So it's been flipped the other direction. And that's the question finished.